Hello, everybody. So I just put a few slides together just to recap what's happened, what's happening, and to have some discussion. People want to chat about stuff. Just first up, what did we almost finish? And we're pretty much done in 2022. I thought it's good to look back at progress. We did a lot in 21, but we also did a bunch of stuff in 22. That's almost done. So things like ZMO. I don't know if Alan just walked in the room, the perfect time. Mr. ZMO. Scale and multiply without divide. RV32, RV64E, these were things that have been around for a long time. We finally got around to pushing those most of the way through ratification. Same with Zvkn as the IHPM. This is something we didn't quite notice. We hadn't separately ratified those extension names. ZTSO is something we planned for a long time, and we're just pushing just that feature that the system is TSO. Notice this is just a static attribute, the whole system. There's a lot more to do if we want to have dynamic TSO. That's not what this is. This is just the whole system is TSO. ZCE, Tarek and friends in the code size reduction did a great job pushing this through. There's a lot of to and fro. I think we have a nice solution. It's I think there's still some toolchain issues, but the ISA design is, I think, mostly done, agreed upon. And finally, a small leftover from the vector stuff, the FP16 support in the vectors is also going through. So that was just a leftover from the vector task group from last year. Okay, so this is stuff that's mostly done, finished, new things that are showing up. So some of the work in progress, some of the fast tracks, the smaller things. One is the iHint NTL. This is non-temporal locality hints. So these are instructions that tell you that the following memory operation probably doesn't have temporal locality in some level of the cache, and there's actually 4 options in a private, all private, in a shared, all shared. And so you can prefix instructions with this. This is waiting for TSC approval to fast track, I believe, is where that is. Another one is misaligned atomics. This is an interesting one. So the current atomics and memory operations are only defined to be atomic if they are naturally aligned. However, it turns out that in particular Microsoft Windows doesn't work. It needs misaligned atomics, so operations, but apparently it's okay if the atomicity granule is 16 bytes. So if your atomic is misaligned, but all the bytes are within a 16-byte atomicity granule, that's okay. So we had a bunch of to and fro about this, partly scratching our heads about why is this needed and why is this okay. The people who've been in the trenches fighting this battle before have informed us of all the grisly details, and this is what it boils down to. After a lot of discussion, we realized this wasn't really an extension. It's just a new kind of PMA. So it describes that this section of memory supports misaligned atomicity within this 16-byte granule, for example. So this is probably going to appear as a new PMA in the Priv manual. I'm putting it here as Unpriv, but that's kind of where it started, but we ended up realizing it's probably just a PMA, a new type of PMA. So the Microsoft Windows RISC-V profile will probably mandate that you have this, okay, whenever that shows up. Coming to a Zune near you sometime soon. Zvkn. So this was a small fast track proposal to add conditional zeroing instructions. They're originally called masking instructions, but everybody agreed that was didn't match the operation, didn't make sense given what it was doing. So these are conditional zero instructions. Very simple. They take one register as a condition, and if that register is 0 or not 0, then the output is either a copy of an input register or zeroed. Okay. There was a long discussion around whether these should have data value independent timing to allow them to be used in cryptography, but it turned out the crypto folks didn't particularly. This wasn't a heavy use instruction for them, and also there are performance advantages to allowing microarchitectures to optimize their execution when, for example, the predicate is available early. You can calculate the result without waiting for the second input. And so the model here is these are only, they're not guaranteed to be data value independent. They don't extend the set of things that are in ZKT, for example. Right, so that's the current proposal. So just 2 instructions here. Very simple one is, conditionally 0 if it's true, then conditionally 0 if it's, well, conditionally 0 if it's equal to 0, or conditionally 0 if it's not equal to 0, those two instructions. So those are the fast tracks. So some of the bigger things that going through vector crypto is probably the highest priority thing right now at RVIA. We're trying to get this done for the RVA 23 standard, and the focus is on the one round at a time versions of these. The all rounds versions, I think we're trying to decouple that from the push to get the single round versions ratified. So the all rounds one do the whole thing in one instruction, whereas the one round at a time do the conventional sort of step at a time. I think the IC definition, as I understand, is almost complete. There's multiple companies have been building proof of concepts around this. One of the things we did when design choices was to support larger blocks. One of the challenges is in the RVA profiles, there's a lot of resistance to mandating vector length greater than 128-bit. So VLAN is 128 minimum in the RVA profiles. Some of the vector crypto would like to work on longer blocks. So some of the other architectures have chosen to provide less efficient instructions that break things up into 120-bit operands. But what we decided to do here is to use ALMOL2, which we can do in our vector ISA. And this allows us to use more efficient instructions. So the belief is with ALMOL2 and the more efficient instructions, we'll get higher vector crypto throughput than other architectures. Now, one of the things to bring up here, it's a good place to bring this up. So the encoding doesn't fit cleanly into the existing vector major opcode. Those of you familiar with vector ISAs will understand that every other architecture has greater than 32-bit instructions for vectors. That includes all the ones that claim the 32-bit. It won't fit in the major opcode we have. And there's better use. It could fit, but in a very unnatural way. So we want to add it in a way that we can more cleanly support it and also support the other things we'd like to add to the vector ISA later, things like some vector bit manip and some other conversions and other things. So what we're going to do, the proposal is to reuse the P opcode, the major opcode for P. The notion is that P and V don't tend to, well, we don't believe people will be implementing those in the same system. P is not part of the application profiles. The smaller embedded cores won't implement V. And so the idea is V will expand into the P opcode. P can also then expand into the V opcode. So that's the model to try and keep things fitting in the 32-bit instruction length. So crypto will go there, as well as allowing future space or future expansion of vector as well within the 32-bit instruction encodings. P, the proximity extension, so the high priority. This is something that's been going on for a long time. Actually started back in 2018 with a proposal from Andes, I think in 2017. They initially proposed this. It's been slow progress, but we kind of tried to reboot this and have more urgency behind getting this standardized now. So there's a new proposal to simplify, restructure those P instructions. The task group meetings have restarted. Still at a slow rate, but the hope is this is going to be the sort of highest priority thing at 23. The highest priority things to get this done. A lot of pent-up demand for having this be standardized, the P extension. This is sort of security. I don't know if it was covered already, but there's a task group started on control flow integrity. So these are adding operations to support tracking the flow control and avoiding the flow control getting hijacked. So basically around the shadow stack and branch target instructions, labels. So the main thing in the ISA we're adding here at the Unpriv level is what we call maybe ops. So Zimops. Why they're called maybe ops is they may be ops or they may not. They're a encoding that is available that on some implementations will do nothing. On other implementations will trigger the security features. And the idea here is you can distribute a binary, including these operations, and if the hardware doesn't support the security features, they're just no ops, and if they do, they'll actually do something architectural. These are different than hints. Hints we define to not do anything architectural, so we couldn't use hints for this. So this is why we're adding a new class of operations called maybe ops, Zimops. And we're still working on, we have an initial proposal, but I think there's some iteration on that in terms of there may need more encoding space needed to cover all the use cases for the CFI instructions. Another thing that's I guess it's sort of, it's a fast track kind of, but it's a lot of little pieces. This is sort of additional floating point instructions, scalar floating point, ZFA. And this adds a bunch of new operations. So IEEE 754, the new min-max operations that handle NANDs properly. Quiet floating point compares that don't do things on quiet NANDs. Round to integer as a float. So we have round to integer as an integer into the integer register. This keeps the value in the float registers. There's also round to the integer mod word size, and this is for JavaScript. So this is basically a JavaScript acceleration instruction. Also, we looked at we're adding a load FP immediates. This is an instruction that directly moves a floating point immediate value into floating point register. And finally, for RV32D and RV64Q machines, those are ones where the floating point flen is twice xlen. And so ZFA adds ways of moving the upper and lower register pairs between float and int directly instead of having to go through memory in those cases. So that's basically ZFA. It's kind of a bunch of small improvements that will sort of fly together. So the intent is, this will be something that will be added to a later profile, be adding ZFA, hopefully RVA23. bfloat 16, so there's a task group that's been, Ken Tox has been driving this, defining this. We had a sort of a not too successful attempt at trying to do a whole lot of alternate floating point, but it boiled down to we just need a few specific instructions to support bfloat 16 for scalar and vector. The minimal support is just conversions to and from FP32, and then there's some simple compute with them as well. So there's, I think this one we're just waiting to, this was not quite as high up in the priority list, but we need to allocate opcodes and get this done. I think most people are agreed on most of the semantics here. One aside here, we get a lot of traffic about alternate floating point formats. People are obviously interested, it's a hot area, all these different formats out there, around FP8, for example. And we have been tracking and working with the IEEE 1309 working group. So this is IEEE has set up a group specifically to work on these narrow floating point formats. For example, FP8. So for FP8, there is 5 or 6 different proposals from the major companies that people are now trying to digest and figure out what to do in that space. So we're tracking that, and there's no great action right now from RISC-V side. As with bfloat 16, anything we do would be non-standard, it would be incompatible with at least one other architecture out there because everybody's doing different things. There's no industry standard in these spaces. Just to mention some new SIG, so we did create the FP SIG with Connie, Meow, and Kenneth Rovers running this. And that they'll be tackling not just the AI stuff, but also the general sort of classic FP stuff as well in that SIG, and that'll be where we'll spawn new task groups. So vector matrix SIG, we should talk about this. A lot of interest in matrix operations, a lot of proposals flying around. This is not an easy space to define an ISA in. It's an easy space to build an accelerator for. It's a lot harder to build a standard ISA that's going to work across many different microarchitectures. So this will need a lot more work, and especially on the software side as well. And there's a lot of overlap with what people want to do in graphics, AI, ML, and traditional DSP. So I think this is something that probably next year we'll be spending a bunch of energy trying to figure out what the common goals are, as much as working. I think it's a bit premature to have very detailed instructions defined in this kind of time frame. Okay, that was a quick run through. I don't know if I've missed anything. Anybody in Unpriv wanting to, if I missed anything that's going on right now? Happy to take questions.
Mike. Just wondering on the vector SIG, whether there's any interest in looking at sort of embedded profiles for vector, or cut down set of vector instructions for targeted in the embedded space.
Well, there is the existing ZVE versions. Is it less than that?
Yeah, less than that.
Yeah, I think people could propose a subset.
Okay.
For sure.
But there's no plans at the moment. There's nothing actively being done.
Nobody's. You're the first person I've heard push for that. So.
Fine. Fine.
just put a proposal together.
Okay.
If it's something that is really a strip down, if it's just subtracting from what's there, that might be
okay.
a lot easier to get some
Okay. Well,
traction behind.
put some together. Thanks.
This is Jeremy. Good. Oh, wow.
A very nitty-gritty question for misaligned atomics. Does that imply that the granularity of PMPs are now going to be 8 bytes instead of 4 minimum?
So sorry, ask again, Alan. I didn't quite get that.
Will the misaligned atomic, well, you have a new PMA, will that also require that the granularity of PMP entries be 8 bytes rather than now the minimum 4 byte, if it's present?
I think it's actually orthogonal. The PMP specification says if you straddle a PMP, you get a trap anyway. You'll fault anyway. So I think it's orthogonal. It might not make sense to have PMP smaller than atomistic granule, but the specifications work.
Okay, so you're expecting traps in that case. Fine, thanks.
Christian, apologies if I missed it on your slide. What's the status of the vector intrinsics description? Because the compiler works working.
Oh, that's a software group that were earlier. Oh. I don't know, actually. I know there's been a lot of to and fro on the vector intrinsics. There is a vector intrinsic task group that just started up.
Oh, didn't know that. Okay.
Yeah,
That's useful information.
but there has been a lot of active development. I think there's been a lot of iteration as people have used them and figured out issues with them. But there is now a vector intrinsic task group. That's under apps and tools software, I believe. So.
Okay, I'll follow up with them. The compiler work's getting to the stage now where really want to nail those down because it's a pain in the neck if you change them after you've done all your patterns.
Yeah, I know. So Alice has given a talk about LVM compiler vectorization this week, I think Wednesday. And all that stuff will be going upstream. So a lot of progress on auto vectorization and LVM compiler.
Other questions?
Yeah, I was wondering about matrix multiplication or like tensor core stuff. Is that already sort of been considered, and does that be part of the vector sig?
Yeah, I mean, there are multiple proposals around. I think it's just pulling together the ones that people want to do and getting agreement on them. I think it's there's a very wide space of possibilities, and narrowing that down is the problem. I think there's many proposals. That's not the problem. The problem is figuring out how to pull them together. And maybe, I think probably next year we should start having the group meets, task group meet to try and get people to, and one group has gone off into more AI graphics, sorry, one group's gone off into the graphic space, which is a bit different than AI. So, transforms as opposed to AI, 3D graphics transforms as opposed to convolutions and matrix multiplies. So, yeah, I think trying to get people together around I think that the other thing is a full set is very comprehensive, will take a long time. So it's more about what are the next 2 or 3 or 4 instructions we can add that will give a substantial boost to most implementations. I think that's kind of where we should try and go with that to get general agreement. And the other complication, of course, is data types. So for example, there was a push for everybody doing one int8 matrix multiplies, but now the community, the AI community is moving towards FP8 and replacing int8. So we could have spent a lot of work doing lots of int8 multiplies and then realize that all the models are moving to some form of FP8, for example. So I think that it's the matrix ops and then the data types. And the other thing is, people are not really building FP64 tensor cores because there's not a lot of savings over building individual FPUs. It's only the smaller types where unfortunately there's more variety. So yeah, a combination of data type, matrix sizes, semantics of the operations, all those things have to come together. Yeah.
Anyone else? Last call for questions. I think we're good.
Thanks.